Welcome. Hope everybody's nice and comfortable, got a nice lunch, relaxed and ready to do a little bit of personal growth. Before we dive into architecture and the levels of design and how to be more than a title in a Visio, wanted to tell you about some of Improving's plans. So Improving runs our business on the philosophy of conscious capitalism, and we really feel that the community is a stakeholder in our business. And that's one of the reasons we support technical communities, user groups, et cetera, in our office. Unfortunately, we can't do that right now. So what we're going to be doing for the next 12 weeks is every Friday at this time, we're going to have a different improver that's a well-known speaker from around the nation coming in and giving one of their talks, either new talks that are specific to the things we're dealing with now, or great talks that maybe just haven't been seen by a broader audience. So that program will be kicking off this Friday and continuing on. This is just the first of those 12 talks. So diving right in, if you don't know me, I'm Devlin Liles, and this is just about everything you need to know about me. Passionate learner. And so we're going to talk about my journey through architecture and the things that I learned as I went, as well as the people and the patterns and the evolution of the thinking that really changed the way I approach building software. Please, at any time, if you want to ask a question, there's a Q&A inside the Teams app. You can hit the Q&A button, drop a question into chat, and Michael Slater here, who's producing, is going to be interrupting and asking those questions and proxying you for us so we can have a conversation. So when we talk about an architect, there's a couple of perceptions that we have to overcome. Some architects are brilliant, insightful thinkers, deeply tied to the technology, but not all of them. Sometimes they're disconnected from reality. They're ivory tower architects, right? I've heard the term dirty hand architects, where they're still getting their hands deep into things. Now, these perceptions, I believe, are actually not caused by the capabilities of the people in those roles, but primarily by a misunderstanding of what levels they're acting in. It's really easy, if I'm thinking about systems integration and application architecture, to be felt as disconnected from the decisions. And that really comes down to, we talk about all these design patterns, we talk about architecture, but we don't separate them very well. And so through the evolution of my career, I've had some great mentors, and we're going to talk about a few of them today, who have helped me to change my perception of what those layers are. And we're going to start it where I started, which is a common way to try and filter out and understand what a person knows is asking this question in an interview. Do you know any design patterns? Can you name them? What's your favorite design pattern? The question has a bunch of different kind of tones to it, but some of these answers that I've gotten and that I've given, right? So I've heard adapter, right? You'll hear the gang of four patterns often thrown out there. And that one's a whole body of different structural and behavioral patterns. Then you'll hear things like event-driven architecture or service-oriented architecture. That one's one of my favorites because a decade in, still don't know what it means. Now, then you get into messaging and integration patterns, you get into data migration patterns, you get into design structures. It gets to be a really long list. So what I started doing as I was exploring this topic and really trying to learn, I started realizing there were some things that I was just far away from. I was trying to learn how to put down the foundation or maybe even a single class or a single method. And I was hearing these talking about how to take these well-built classes and methods and build a solution from them, and then how to take these well-built solutions and build integrated systems, and then how to build those systems into these giant enterprise architectures. And I just wasn't there. And so we're going to start that same journey. We're going to start with the technical design. That's going to be the first place we move into. Now, the technical design is primarily around how do I structure a solution to problem X? How do I get this method to do one thing? How many methods do I want in this class? What's this class's responsibility going to be? It's really that small tactical decisions that we make every day while writing software, right? These are oftentimes the decisions that when you ask a technical lead or an architect why they did it, you're going to get varying answers. Well, that's the way I was taught, or, oh, it's better than that way, with really no backing behind it. What are the primary things that you need to worry about when you're in technical design? So there's a couple of core pieces of architecture at this level. And this is the level of architecture that every person who has commit rights in your code base is impacting every day. Every pull request, every commit is going to change the technical design of the system. And so we need to be able to have a kind of strong foundation. This basically boils down to cohesion and coupling and responsibility assignment. Now, coupling and cohesion are great interview terms. People throw them around, but what I have found is that we violate them frequently. And this was such a prevalent thing that when you hear the solid patterns, half of them are talking about building cohesive, decoupled applications. Cohesive and decoupled classes. So when I talk about single responsibility, I want one thing for that method. I only want it to have one reason to change. That doesn't mean it's only going to touch one piece of data. Doesn't mean that it's only going to have one or one if statement. It means that it has one purpose, one responsibility. That can get pretty broad though. It's pretty easy to go, well, its purpose is banking. Well, okay, but maybe that one method, its purpose is really accepting a deposit and recording it in the general ledger. Checking account status. Like, those are more fine-grained single responsibilities. And so you have to break the responsibility down, and then you have to ask questions around what's going to happen with the cohesion and the coupling of the class if I put that responsibility here. Now, imagine if you're taking a purely object-oriented design approach to class design, and you're familiar with the Sapir-Whorf hypothesis. If you're not, here's what it says. There's a great movie that could basically be described as the Sapir-Whorf hypothesis as a movie called Arrival. But it says that as you change language, you change the way people think about things. And so in software design, we want to use the language the business uses in our software because it will change how we think about building the software. That's all it says, really basic. Now, if I do that and I want to print a document, there should probably be a print method on a document. That's what that says. It's great, but to print a document, there's some additional steps. There's additional dependencies that I have to evaluate. I have to look at it and go, okay, is every document going to have a printer injected into it via dependency injection or my inversion of control container? And then, okay, maybe, but I only have one method in a document that's going to use that printer. And so I'm breaking down the cohesiveness of that class by having this thing that's only used once at the class level. What if I were to pass that printer into the method for print? And so the document's job is to translate itself and send it to the printer. That's better. Now I've got a cohesive class because I'm not sharing class level variables. I've got cohesion in my method because it's using that. But now my document is no longer responsible for just translating its format and sending it to a printer. It's also now responsible in knowing how to interface with all the different types of printers. And then you end up with a giant switch statement and et cetera. That's probably bad. And at that point we go, okay, how about we create an interface for printer so that I'm not creating coupling to all those classes. I keep cohesion in my method and the responsibilities are assigned. And maybe I actually have a document translator that I inject, and the document translator is the thing that has the printer in it. And so you can see how just the micro decisions can change your class layout, your method layouts, and those kind of things. And you see the principles, and we've talked about the first one, really play into this space. We talk about being open for extension, but closed for modification. I should be able to extend on that class and add additional behavior without breaking the existing behavior. I shouldn't have to go modify the print method to support a new printer, as long as the API is consistent, right? If I wanted a print to PDF, I should be able to use list-off substitution on my interface for that printer. And the iPrint interface, I hand in a PDF printer and my document shouldn't care that it's now no longer going to a physical output, but a digital one. We talked about it slightly a little while ago about injecting a printer at the class level through dependency inversion. That inversion of control that takes my dependencies of the class and makes them the problem of who's constructing the class, right? The person who's calling the print method has to tell me where to print it to, versus the document owning all of that decision making. Now, the outcome of this is that we spread responsibility out, but that our code gets much, much simpler at the micro level. And there's a lot of supporting patterns to do this. There's your factories and your builders and your prototypes and all that. There's singletons, and there's the entire dependency inversion and IOC space. All of these are meant to support those technical design solutions at that bottom level. And this is a space that most of us, we get the patterns that we're used to, and then we kind of stop. When I learned strategy pattern, everything was a strategy. I had strategies of strategies, and my strategies had strategies. Like, it went crazy, and it wasn't good software. When I learned command pattern, everything was a command, right? When I learned, query pattern, everything was a query. When I learned specification, everything was a specification, because that's how we learn, is we then look and we've got this new pattern that we've internalized and we apply it out to everywhere to see where it fits and where it doesn't. And when we find that problem space that it works very well with, it becomes our habit. When we have enough of those habits to be successful in our job, it's the rare few who continue to grow new habits they don't yet need. And that's where those true kind of dedicated personal growth, we like to call them improvers, that's where they come in, is they continue to grow past what it takes to be moderately successful. Now, if I were to move on and talk about the next layer past that, we're going to assume that you've gotten technical design pretty well handled. You can build good, single responsibility, cohesive classes. You can assign responsibility properly to them, and that the pieces, the Legos of your application, are well-built, testable software. But now we move into solution design. How do I take all of these disparate pieces of data and functionality and combine them into something that's valuable, that accomplishes a business goal, that really drives forward to what my customers are looking for? And that's solution design. So when we get into solution design, we start looking at a whole lot of different problems. I'm going to switch over to black. Hopefully it's easier to read. We start looking at different problems, because the problems we have in solution design are one of coordination. They're collaborative. And based on the pieces involved, that collaboration changes. And so we end up at this point talking about multi-class coordination, and we talk assignment of ownership. These are the two kind of core design premises that I learned as I was evolving through this. I have my class, I have my methods, it works really well. Awesome. Now I've got to plug it into the controller in my MVC app. That's multi-class coordination. Now, MVC is a design pattern that dictates the coordination and collaboration of different classes for a goal, which is to provide a view of usable information to a consumer, right? There's different ways to do that. There's the MVP pattern, there's MVVM, but they're all collaborative patterns in this space. When you're talking about systems integration and services and those kind of things, you'll see things like composite and bridge and decorator patterns, which are intended to allow the collaboration of multiple classes to drive towards some business endpoint, whether that is audit trail or history or versioning. There's a bunch of different patterns that are used to accomplish those goals. But there's one other piece here. We start assigning ownership of both data and behavior. Who owns the data? Comes down to a couple of pieces of when classes are collaborating, then I'm going to have multiple classes reading data out of my class. I'm probably going to make some of the properties and methods public. But who's allowed to change that data? Is it okay if I have a document manager and that document manager can then go rewrite the document by just reaching in and changing the properties of that class? Or does it need to call methods on document where document itself is making those changes so that that responsibility stays in one place? So you start assigning who owns the data, because I'm going to view it, but I don't own it, has a whole different design approach than the kind of public by default practices that I see in a lot of code bases, where everybody can change properties, everybody can call methods. The kind of tenets of design for collaboration is one of isolating behavior and really being able to separate concerns. And we separate those concerns through abstraction. We want to make sure that, yeah, you know me, I introduced myself, but unless you're my wife, you don't have my social security number and my birthday. And if you do, please give them back. But that's abstraction. I've given a public API. I've told you information you're allowed to have. And the information that I don't want to be shared publicly is not written on my t-shirt. If we take that approach into code, are we going through and evaluating our methods, our properties, our interfaces to ensure that they're the right level, that we've got only the things that need shared as part of a public contract? Because the other part, and we'll get into this here in a little bit, is once you've established a public contract, you've got to be really concerned with changing it because you can break all of your consumers. And so in solution design, we start worrying about these things. The assignment of ownership is a big part of that. So now if we go back to our kind of design idea of a document that needs printed, I've got a document, I've got a printer, I've got the interface, we've built it well in abstraction. But who owns the IP address and communication protocol for that printer? Is it the factory that creates the printer? Is it the network management class? Is it the document? Right? Those assignment, who owns it, right? Who can change it? Who can scan the network and update it? Or does it scan the network, detect it, and go, hey, the DNS name for this object is there, but the IP changed because it lost its DHCP lease or something. I'm going to tell the printer to refresh its IP, or I'm just going to go change it. Those are the design decisions we're making at this layer. And they get really dicey because when you get these wrong, you can probably get it to work. And that's the worst part of this. In solutions design, failure isn't felt by the person designing the problem today. It's felt by the person having to make modifications 2, 3, 5 weeks from now. Now that may be you, it may not be you, but that's the person you're worried about, because most of us can go through and we can bang on it. And even if we've made a lot of mistakes, we can get it working. We can pass the business requirements. It can be okay, right? So we're looking really at this level to make sure that it's good enough for our future self to not hate our current self. Now, as we move on and we progress into our next layer, we're going to assume that you've gotten solution design pretty well done, that you've been able to build modules and applications that are delivering business value. But a system is a combination of those things, right? If I have a online ordering portal, and on that online ordering portal, it then creates orders. Those orders go to my fulfillment system, and then after fulfillment, they go to my accounting system to be invoiced and paid for. Those three software packages are the system that we're interacting with. And you have to look at a whole different layer and a different set of driving design principles in this. Now, one of the key design principles is visibility of data. Is it appropriate in my fulfillment system to publish a screen that has all the accounting information that shows whether that vendor who produces that part hasn't paid us 6 months? Maybe, right? Maybe not. It actually put that visibility in the accounting system, and the only your fulfillment system is not to order from that person, right? Not send them new business until they pay us, those kind of things. Yeah, we're having, all orders are on hold with this vendor because we're renegotiating contracts or because we're moving to a new vendor, those kind of things. And so visibility of data becomes very important, but then your long-term sagas that your customers are going to go through start to show up here in a big way when you're collaborating across systems. So customer journeys and data journeys start to drive a lot of your design thinking. If I'm looking at an order coming into my website and I want to make sure that it's going to get fulfilled in a timely manner, I'm looking at lead times. I need data to flow back up to my website to give an estimated delivery, right? So our customer journey want to know when their product is going to be delivered is different than our data journey because that's actually pushed from our fulfillment. So these collaborations between the software start driving the design approach of the majority of what we do. Those practices start to change, and you start seeing things like messaging and integration patterns. You start seeing enterprise integration patterns, which is a fantastic book. And it is, how do I meet A and B needs so that we can solve this problem that's crossed those spaces? Now, we've gotten pretty good at this, patterns and some common tools, but with the advent of microservices and distributed architectures and edge functions and serverless environments, it's getting even more important because previously systems would talk to each other and integrate, and they'd integrate at the database level. And if they were really advanced, they'd have like an ETL process that shipped data around. That was 20 years ago. Today, I've got APIs that I can ping at will in my fulfillment system to get lead time by product and vendor as quick as possible. I've got APIs with push notifications and dual direction WebSockets that allow me to surface data from 3 systems down the stack to my end user immediately. And so you start seeing these processes speed up. The amount of data moving is far more important. Now on this, it is not specifically a design pattern, but it is something at this layer that you have to solve. Now you can consider it at the solution layer based on your business program and the data you're handling, but at this layer you have to solve it. How are we protecting our data while it's moving, right? Are we using secured communication protocols between our client and us? Are we using secure communication inside our network? Do we have proper restrictions? And most developers, and I'm one of them, will just have this gut-wrenching feeling that that'll slow down development. But in the world we live in today, not making those choices at this layer can land you on the front page of a newspaper in a very bad way when somebody breaches a system and your competitive advantage goes out the window. So the architects at this level are thinking those problems. They're much closer to the business. They're typically future looking because they've got working systems. They're trying to integrate them for some future business case. And they're really digging into that extra layer of what are the concerns we're trying to stay out in front of and how are we moving? Now, the second one is, what do we do with our data at rest? Because we now have 3 systems that are all interacting. And do they each have their own database? If so, do we have correlation IDs that allow us to bring together and go, this order kicked off this order from a customer kicked off these fulfillment requests that kicked off these invoices, and being able to tie that back for reporting and making sure that, we're not missing invoices or we're not going critically low on inventory. You have to have those kinds of integration patterns. Or do we pull it together into a central database and separate it by a schema, which comes with its own problems of now everybody's playing in one pool, changes become harder, right? Do you have everybody with their own, but then reporting is done off of a data warehouse where you pull all of that data and you get into master data management areas, right? Do you create a data lake for real-time and near real-time analytics? These are questions that you're asking at the systems level because the person who designed the solution, who designed that application, was solving a problem for one business area. The person who's designing the integration of all those systems has to look across multiple business areas. Now, there's an extreme version of this type of design that we really need to talk about. That extreme version is enterprise application architecture. Now, this is not enterprise architecture. Enterprise architecture we're going to talk about in a minute. But this is those giant enterprise applications. These are not the common kind of practices and patterns. They're just not. Because you don't use the same design patterns to build a house that you use to build a skyscraper. When I'm building an integrated application that's working on a single database that serves 14 business units to give us one operational platform, that's a whole nother level of design. And typically you'll have multiple architects working in consort on an architecture team at this level. And each of them will have their responsibilities coordinated by somebody. Because being a messaging and integrations expert, being a information and UI design and user experience architect and expert, while also being a data design and storage expert, while also being a software design and solution systems integrator expert, having all of those be one person is near impossible. And even if you found that person, the amount of work that goes into an enterprise application means that person would never sleep and still would fall behind. And so when we talk about these, this is where you'll start hearing about things like domain-driven design. Those are a set of design patterns to break up really large problem spaces. Now, can you use them in smaller applications? Absolutely. But they really shine in enterprise application architecture. When you start isolating domains and you get very explicit around the boundaries for data visibility, because it gives you a set of patterns to follow in the technical design, in the solutions design, and the systems design. But it gives you a set of reliable patterns to deal with when you integrate all of those across, because you've got some things that you've got to figure out at this point, right? At this point, you're going to start looking at kind of collaboration flows. You're going to look at kind of long running, long runtime processes. And you're going to look at asynchronous start and end. Enterprise applications have some unique things about them that make them harder to develop. But there's some patterns that are really well set up to do some of this. You might have gateways to each of your third-party integrations. You might have a mapper structure that would allow you to translate disparate data sources into a canonical set. You might have a layered super type that allows you to structure your metadata. those are fairly specific problems that you need fairly specific design patterns for. Let's talk about asynchronous start and end. So the asynchronous start and end is a requirement that typically comes from the business like this. So after a customer orders from our website, I need to notify fulfillment and customer care. And when fulfillment gets the product in, we need to have customer care reach back out to the customer. Okay, so customer care doesn't actually need to get a heads up until the order actually has a product back from fulfillment. So not only is the creation of the order a requirement, but so is fulfillment getting back. And that's a fairly simple example. It's only 2 triggers. What if you have 5 or 7 triggers? Hey, when this happens and these following events happen, and then somebody does this, this process needs to be fired off, right? Hey, when we get a payment into the accounting module, we need to go clear up available credit for them to go do additional work in this other module, and we need to reconcile the general ledger, and we need to do these things. And when those are done, we need a process to kick off that puts their account back in good standing. It's like, whoa. And so you start hearing things like sagas, and you start seeing monitoring systems that allow for watching for these event triggers and kicking off processes that a human being's not kicking off. It's a combination of system state in multiple places. And so enterprise application architecture gets really deep. I've met a few amazing people in this space. At each one of these layers, I've been blessed with mentors. When I was struggling with technical design, that was Jay Smith and Rob Tennyson and Mike Pitts. And then when I really got into solutions design, I started into systems design, I was sitting 6 feet from Tim Rayburn and Craig Newart, and it was like, wow. And then in enterprise application architecture, I got a master's class in this from Tim on the distributed system side, from, wow, I totally just blanked. I just dropped a name entirely, sorry. I'll pick it back up, I'm certain, at some point. But I got a master's class from these great titans that taught me some of these things. The one person that really drove a lot of this home is the next layer that we're talking about. And interestingly enough, this wasn't a super deep coder anymore. I was kind of going through, and I was really starting to evolve and understand business and how technology plays into it because of an evolving role I was taking on, becoming more business focused, understanding the needs of our clients and those kind of things. And Curtis Height gave me some sage advice that led me down the path of looking at enterprise architecture. And I really got into kind of trying to understand what drives businesses and how to interweave research and R&D, enterprise applications, systems design, and business fortitude. And Curtis Schlack was fantastic at this. He still is. And I watched him coordinate a huge amount of these efforts from some really talented folks, all with this vision to prepare the software to solve a problem 2, 3, 4, 5 years from now, and problems that we couldn't even imagine. It was really cool to watch and experience, because enterprise architecture has very little to do with the architecture of each individual application beyond a basic level. What you end up with is somebody that's looking at emerging technologies. They're looking at future trends. They're looking at where technology is going, balancing that to where you're hiring, right? If Ruby is fantastic for solving a problem, but there's no Ruby developers in the market, you might actually choose the second best tool because you can recruit for it, right? And so the enterprise architect is really looking at a lot of those things and how they interplay. This is the person that's advising a CIO typically on the future game plan and the R&D for a company, the kind of technical direction. They'll probably end up coordinating and heading an architecture committee. And there's some really good stuff from the open group. TOGAF's got some good frameworks around this. But it really is being that trusted advisor, that technical confidant Now, if we were to go all the way back to the layers that we had talked about, and I'm going to start down here with tech design. Then you get into solutions. Then you get into systems, right? Then you get into enterprise application. And enterprise architecture. I've met a great number of people that are good at technical design. I've met some amazing folks. I mentioned a few of them earlier. And a few of them end up stepping up here because their job evolves. They get promoted to lead, they take on building a new application, etc. But there seems to be a pretty stark fall off in the number of people I meet with these skills between solutions and systems. And one of the patterns that I've seen in this space, you can keep kind of 2 layers of expertise pretty well. But it's pretty hard to have enough time, bandwidth, and learning to really get into systems integration patterns. If you haven't mastered this one, it's near impossible if you've got a team of 5 or 6 people and you're trying to make sure they're learning this while doing this, you're going to be pretty overburdened on time. And so there's a big fall off of the number of people who are good at these because they're still spending the majority of their time here. And the same thing happens. So you end up with these kind of layered buckets where the folks who operate in these layers are typically in one of these 4, right? They're the enterprise application architect who's a savant with systems design, or they're the system and solutions design savant that just puts together well-built systems in a certain scale. And they don't really go above that scale, but they are great at it, right? You've got the senior developers who are great at building applications, who can drive things forward, and they're great at just slinging out a lot of code as well. But when I spend, 40 hours researching new technology and presenting an opinion on where I think our company should go in the next 5 years, and then I go and I spend another 40 hours trying to make sure that all the module integrations in our enterprise application are there, where do I get the 40 hours to make sure that our messaging system is well designed, or the 40 hours to make sure that the applications meet the customer's needs, or the 40 hours to review all of the pull requests from all of the teams? So having a person do all of these is near impossible, but we talk about these folks and we call them all architects. And so it's more than a title in a Visio, but a lot of the perception is because we muddy the waters between these terms pretty heavily. And as we progress through this, I learned this lesson and realized that there was a barrier by which I wasn't going to be able to operate unless I learned to trust the people around me and I grew more people that I had trust in. And so when I hit this barrier, I started coaching and mentoring people the same way I was coached and mentored, so that I can make the step from solutions to systems, because I had people that were doing tech design and solutions design that I was working with that I trusted, and I didn't have to go through and do line by line code reviews and spend 45 minutes reviewing and advising them on how to do better on a 15-minute task. And then when I hit this barrier, and I was doing systems design for a while, and I wanted to do enterprise application architecture. I really wanted to play in that space. I had to get to the point where I was okay letting go, and not only letting go of the tech side of it, but even letting go of the coaching and mentoring of the people who were going to be reviewing it. And I had to start playing in that system space and trusting that the teams that we were working with, those were the people I was going to be investing in, and I was going to be mentoring them and then trusting them to carry it forward. And they were going to trust the senior devs to mentor the junior devs, and it created this kind of this built structure. And the irony of it is, I did all of this and I went through this progression and I learned all these lessons without ever realizing they were entirely based on trust. They were entirely based on seeing competency and then expanding that competency and then investing in people. All of the things that I truly loved, these were built on, and I was like, wow, an effective team that can build a well-architected application is pretty heavily based on trust and a progression of skills that's going to hit some ceilings. And all it takes is a mentor, somebody with some advice, and the opportunity to go past that ceiling if you're willing. So we're going to open it up for some questions here in just a second. I know that Michael's been kind of monitoring those. And the second piece of this is just an offer. If you have questions, you're like, hey, I'm at one of these layers and I want to move to another one, reach out. My email is going to get published as a part of this through social media and all that fun stuff. Feel free to reach out and I'll point you where I got pointed to. So, Michael.
My first question is going to be from Vita is, are there any good pointers on moving into the enterprise architecture role specifically?
So making the move, great question, Vita, thank you. Making the move from enterprise application architect to enterprise architect is a tough one. I'm going to give you kind of a reasoning based on numbers for this. So if I look at the number of applications in Houston that are built kind of at this systems and solutions layer, it's probably in the thousands, right? There's probably thousands of those built every year. But 3 to 5 year multi kind of module enterprise application architecture type applications, maybe kind of 1 to a dozen are active at any given time in each market, and those are major markets, right? Like I'm assuming that like LA, New York, Dallas, Atlanta, they'd probably all be similar in scale. And so this progression gets pretty hard. And if you're trying to jump this way and go from systems up there, then you've capped the size of the organization you can advise because there's a whole series of problems you've never seen, right? And so when I do this, not every company has one of these. Not every company realizes they need one of these. And to be frank, not every company needs one, right? So the number of companies is pretty small that have those roles. There's typically internal people who have gone through that progression that they're targeting for that because of the existing trust and competency and history. So it's tough. If you're looking to make that move, gaining the experience, really trying to find this, right? Even if that means moving, right? Moving between cities for a couple of years because there's a project which will give you this experience, really leaning in and reaching out to enterprise architects in the space and learning from them and getting connected. I know there's a couple of different enterprise architecture meetups around the US that are digital, and getting connected into those will really help. And the second piece is start paying attention to the business trends inside your organization. Because even if you're not looking to move and you want to stay where you're at, you can become that long before you have that title. I know that we have a significant number of folks who have done this for us in the past, and I've seen a lot of folks that our clients do this. And interestingly enough, the ones who are diligent and that they do it for the benefit of the company and themselves, they're creating that win-win, they're the ones that succeed because they're the ones that are going out and they're watching the trends for technology, for the market. They're going, all right, how could that company? And then they're building out the prototype to try and prove the value. They're not waiting for an invitation. They're not waiting to be told, yes, 1 week out of 4, you can go build those prototypes, diving in. And then they're going with not only a recommendation, but a recommendation, some data behind it, and a proof of concept that could generate value for the company. And when you can build that story and you're willing to invest that time, it garners a lot of trust. You do that a few times, this role probably gets created for you.
Yeah, Devlin, you may have answered some of this just now, but how do you see the value of the enterprise architecture conveyed throughout the larger team and business?
So enterprise architecture is a tough one because it's future looking, and it's a lot like buying insurance. Now, the funny thing is, we can see the visible effects of bad decisions and good decisions, both from the outside, but we can only see them as a lagging indicator. It wasn't very long ago that Amazon was a bookstore. Why did they position themselves as a general retailer and rewrite their web portal to support products and a bunch of different providers. And then once they had done that, they then built deployments, built, shipped by Amazon, that. And then they started content delivery for books, digital books at this point, books, and then music, and then video. And now they've got pantries and they bought Whole Food. Like the progression of technology that fueled that had to be for those trends weeks, months, and years ahead of the time. And that's ignoring entirely the AWS space, building up the server technology to handle the kind of load that no other e-commerce provider on earth had ever seen. And so you see what successful application and architecture looks outside on that one. And I wish that I didn't have this as an example because I used to be a very loyal customer of theirs. But you can see what bad enterprise architecture looks like, or the lack of it. Blockbuster had a chance to buy Netflix. Everybody tells this story, but the real story is worse. The story goes, they said no because they thought they could build a better version cheaper, and they did. They had faster subscriber growth than Netflix. They had a rent line return store and a bunch of other stuff. It was going very well. Unfortunately, falling prices and falling revenue, et cetera, the franchisees, the brick and mortar stores, that wasn't a great thing for them. And so there was a change in the CEO and a change in vision for the company, and they mothballed their streaming product. They had had a trusted advisor to the CEO, to the CIO, that was looking at the trends in the market, was looking at the digital media explosion. Maybe they would have spun off a subsidiary who could have ended up continuing on the company name and brand to do the digital media without cannibalizing their existing business. Maybe they would have gone to the franchisees and done something there. Maybe, but without that trusted C-level, the lack of an enterprise architect, we typically see when companies go out of business because they missed the wave. Hopefully that answers your question.
Yeah, Devlin, I think our last question might be, within the context of agile transformations, what are some ways an enterprise architect or any of these roles can contribute?
Absolutely. So contributions inside an agile transformation typically trend towards supporting changing modes of working. Oftentimes, our infrastructure, our hardware, our software of working will kind of follow a path. It becomes almost groupthink-like, in which, okay, so we do status emails, and so we actually created an automatic status, a status summary sheet that comes out of our time tracking system. Okay, that might need to change if you're not doing status meetings, but you're doing stand-ups, right? Digital boards and integration, those kind of things. And so you can contribute at kind of every level. The EA level is probably before the agile transformation has even happened. Before it started, I'm having a conversation about, hey, if we're going to change the modes we're working in, we should change them in a digital space, right? Making it a business agility transformation rather than just a change in the way IT builds projects. Getting the business involved so that you've got effective, high caliber product owners and really aligning IT as that critical partner rather than the cost center. Really changing the perception of the IT professional, which is something I'm a little passionate about. At the enterprise application architecture space, if you're working in this space, it could be changing the methods and modes of which you're designing the system so that pieces of the system can release on different cadences. Now that requires different design solutions, that requires versioning of APIs and some other technical proficiencies. However, it allows your teams to have very sprint but central. It allows for rapid innovation in individual spaces. It doesn't have to be big bang releases and war rooms for a month. At the systems and solutions level, it's focusing in on simple integration MVPs so that you can deliver business value very, very rapidly, and not doing the technical scope creep. Happens when, oh, but the business will need it, right? And focus on internalizing those agile values and principles and how you progress. And at the technical design layer, the most effective way I've ever seen to support a team that's moving into agile is adopting test-driven development. I'm a TDD zealot because it drives the technical design into your bones. Like, I got a La Sala, and he spoke for almost 3 hours, 2 presentations back to back, and amazing fell out of this guy. How to code that way? And his answer is the same today as it was then, test-driven development. And now he's moved to driven development and Gherkin language, which absolutely is where you progress. It'll make the agile adoption and the to new modes of working more successful, because the problem ultimately is not one of technology, one of modes of working, and tearing down some of our groupthink thought processes of this is how we've always done it. Awesome. Well, I appreciate everybody taking the time. Thank you for hanging out. Next week, Tim Rayburn will be presenting. The details of that one will be coming out here very shortly, and look forward to seeing you guys for the next 11 of these. Have a good day.